Greetings, Physics 111 students, and welcome to Captain Rod's video session here. Making this one to help you out with Unit 4-3, number 10, and this will be the only problem in this video. So it says something about a lab instructor has an aluminum cup, which I've got in my picture here, that's got some water in it, and there's a copper stirrer there. Always start these things with a picture like I've done. It doesn't have to be a great picture, just something to kind of represent these things. Now there's a bunch of data given. All those masses, I believe, are given in the problem. So, right off to the side somewhere, mass of the copper equals, mass of the water equals, mass of the aluminum equals. And these are all things that you can look up specific heats for. So I would look those up and write them down. Specific heat of copper equals, specific heat of water equals, specific heat of aluminum equals. And you're probably going to want their initial and final temperatures too. T initial copper, T initial water, T initial aluminum. And then they're all going to have in this problem probably the same final temperature. So write out all the data, get that written in the problem. Now here's the thing. This is how this stuff kind of works here. The water and the copper are both at 27 degrees, but the stirrer was initially at 86 degrees. And then it's stirred until equilibrium, and then there's a final temperature of 32 degrees, okay? So some things to notice here. There's no phase changes in any of these temperatures. You got to be careful. Make sure of that. But none of these things are going to melt or freeze or boil or anything like that in all these temperatures. So what's going to happen here is we're going to have a heat transfer from the copper to the water and from the copper to the aluminum. Well, if we took the heat transfer for the copper plus the heat transfer for the aluminum plus the heat transfer for the water, these should all add to zero. I usually use the, like the classroom. Let's say we got Bob, Jill, and I don't know, Captain Rod here. Maybe I give Jill $10 for some reason, and then Jill gives Bob $5, and then Bob gives me $20 or something. When it's all said and done, let's see, I'm going to be plus 10. Jill, it looks like, is plus 5. Bob's minus 15. But if I wrote the change in value, change in dollar for Bob, plus the change in value for Jill, plus the change in value for Rod, they would add to zero. Same thing is happening here. Okay? So equation-wise, that's how that works. And each of these is an MC delta T term. Put the appropriate masses, appropriate specific heats. Now this delta T for this one is going to be T final minus T initial for the copper. When you do the delta T here, it's going to be T final minus T initial for the aluminum, and the delta T here is going to be T final minus T initial for the water. But they'll all have the same T finals. And anyway, when you write everything out and then put all the unknowns in the equation, I'm sure the mass of the aluminum, which is going to be in this term right here, is going to be the only unknown. So that should get that problem done for you. I hope you're having a great day. Look forward to seeing you in class.